Hello guys, my name is Mohammed Anas of ECE third sem studying in Sri Venkateswara College of Engineering. In this video, we are going to learn about half adder and full adder. First, definition of half adder. Of a half adder is a basic digital circuit that adds two single-bit binary numbers. Important of hash adders, it forms the fundamental building blocks for more complex arithmetic circuits. Components of half adder is it consists of two inputs A and B and two outputs sum and carry. As you see in this figure, the truth table of half adder input output. As I told, input is A and B, output is sum and carry. If we give input A equals to 0, B equals to 0, then the sum will be 0 and carry will be 0. And if A equals to 0 and B equals to 1, then sum will be 1 and carry will be 0. And so on, A is 1 and B is 0, then sum is 1 and carry is 0. And so if A is 1 and B is 1, then sum will be 0 and carry will be 1. The basic algebraic expression for half adder. Sum equals to A XOR B, carry equals to A and B. Half adder, this is the half adder logical diagram. See as here XOR gate and AND gate. S is equal to X dash Y plus XY dash and C equals to XY. Now we are going to see about full adder. A full adder is a combination circuit that performs the addition of three binary digits. Important of full adder, it can add two single-bit binary numbers along with a carry from the previous stage. Components of full adder consist of three inputs A, B, and C in, and two outputs sum and carry out. Means sum and C out. Truth table for full adder. As you see here, if input and output. In input A, B and C in and in output C out and S are given. If A is 0 and B is 0 and same as C is 0, then C out will be 0 and sum will be 0. And so on. If AB is 0 and C is 1, then C out will be 0 and sum will be 1. And so on. A will be 0, B will be 1 and C in will be 0, then C out will be 0 and sum will be 1. And same and A will be 0 and B and C in will be 1 and C out will be 1 and the sum will be 0. In the output, A will be 1 and B and C will be 0. The C out will be 0 and S will be 1 in the output. And if so on, A will be 1 and B will be 0, C in will be 1 and C out will be 1 and sum will be 0. And so on. And at last, if A is 1, B is 1, C is 1. And in output, we get C out will be 1 and S will be 1. The Boolean algebraic expression for the full adder, sum equals to A XOR B, XOR C in. C out will be A and B or C in and A XOR B. The digital system design, the combination logical design binary adder subtractor. These are the objectives. The comparison between half adder and full adder. Half adder adds two single bit binary numbers with full adder adds three bit binary digits. Full adder consists the carry from the previous stage where half adder does not. This is a comparison between the half adder and full adder. Applications of half adder. Used in simple arithmetic operations in digital circuit, build blocks from more complex arithmetic circuit like adder and subtractor. A and B are input in the half adder circuit and S and C out will be C means carry out will be output. This is the logical gate of the half adder circuit. Now, applications of full adder in integral part of multi-bit addition in process and computers used in data processing unit for arithmetic operation. This is the logical gate diagram of full adder. The conclusion: half adder and full adder are fundamental building blocks in digital circuit for performing binary addition. Understanding their operation and design is critical for designing efficient arithmetic circuits. Thank you for watching my video.